The next talk is going to be by Andy Shaner, and it's Scientists Should Engage Young Students, Why and How. So whenever you're ready, Andy.
Great, thank you. So I don't know if it's fortuitous or maybe it was planned that yesterday Amy Fagan and Ryan Watkins were talking about importance of mentoring and the next generation, because there are two elements that I'll be addressing in my presentation this morning. Sorry. There we go. So just from the National Science and Technology Council's Committee on Science, Technology, Education, and Mathematics, or STEM Education Committee, that basically, like many of us, all of us know here, to really be able to function well in today's society with the technology and with what we see going on with the pandemic, people really need to be good about having good evidence-based reasoning skills. Okay, but there's a problem, at least here in the US, with that. Across numerous national assessments and even international assessments where American students are compared to international students, they don't do so hot. So this is just an example of data results from one study, from one assessment that's done over multiple years. That's done over multiple years. And you can see, at least in terms of how people's students score being proficient level or above in science, that level is pretty low of how many students in those grades are proficient. And these assessments not only assess their content knowledge, like what's a rock, but also this process of science knowledge, skills and knowledge. How well do they understand that? This leads a lot. So what we see is a lack of interest in science among students, which is ultimately leading to a lack of STEM professionals in the country, which is becoming more and more of an issue. Lack of interest can be directly related to someone's attitudes towards science. Here on this slide, these are just 4 examples of different indicators or different things you can measure to consider what is somebody's attitudes towards science. This is not comprehensive. It's quite a long list of things you can look at, but I just want to put these here as an example. So from research, we do know that secondary students in particular possess poor attitudes towards science and STEM in general. But we know that if we can increase those positive attitudes towards STEM, it impacts their interest in pursuing careers, enrollment in science and mathematics courses, particularly at the college level, but even participation in STEM activities. And I italicize that because it's very important to remember that not everybody's going to be a scientist or a STEM professional. It's also just as important that we have STEM proponents, science proponents out there in the country supporting science and scientific research. So what can we do? Well, we can do there's 2 things we can do. This is not inclusive either, but we can allow students, give them opportunities to participate in authentic science experiences, and I'll tell you what we mean by that. And also giving them time to interact with scientists, the opportunity to have scientist interactions. If we can do at least those 2 things, and there's other things we can do as well, we can improve attitudes towards STEM, science, and increase the number of STEM graduates and also STEM professionals in the workforce. So what do we mean by authentic science? Well, basically that just means students participating in authentic science are doing the things that you all do every day in your career as a scientist or as an engineer. That's authentic science. More specifically, if you look at the next generation science standards as a kind of like it's your baseline, it's what your go-to for what those practices are if you're looking for a definition. It includes some of those. That's not comprehensive either, but that's just some of the things it includes: asking questions, developing theories, looking at and analyzing data, all that kind of stuff. And when they do participate in authentic science, we know that it improves their perspectives and involvement with science. And it also promotes understanding of the scientific process. It gives them empowerment to do science, and helps them to develop an identity as someone who can do science or as a scientist. Interacting with scientists, they're very beneficial, but uncommon. And we also know from research that if they do get to talk with scientists, students are more likely to pursue careers, they understand the scientific process, and they increase their positive attitudes towards science. So really, from that perspective of science interaction, is it helps students see that scientists are people. They're not isolated in a lab. They work in groups. They work together all the time to solve problems and to solve questions or answer questions. So the LPI group of CERTI, the Center for Lunar Science and Exploration, we have led this program called XMASS for short, Exploration of the Moon and Asteroids by secondary students, for almost a decade, with an earlier version of it under the NASA Lunar Science Institute. And what we know through pretty rigorous evaluation and even a study looking statistically analyzing some surveys, this program gives high school students a chance to engage in authentic research while stimulating positive attitudes. We're increasing their positive attitudes towards science. Our program in general provides a foundation of lunar and asteroid science. Most high school students don't know much about the moon or asteroids coming in to high school. Provides student teams a research advisor, a practicing scientist, get an emphasis on student-led research. So they're not researching a scientist, helping a scientist gather data for their project. This is what the students want to do, and they're leading it with the guidance of an advisor. It provides the students an opportunity to collaborate and communicate research with peers and scientists. And it gives scientists, it gives you all an opportunity to advise and train a future generation of STEM professionals and proponents. Can't stress that enough. Not just the researchers, but the folks out there that come and hear you speak. On the left, there's a map just showing you the locations of schools that have participated in our program from the very beginning. The ones that are in pink are the ones that will be participating this fall, starting in the fall. On the right is a location of where advisors and judges, I say judges because at the end of the school year, teams, they present their research as a poster, and those posters are scored. So this is locations of where judges and advisors have been. So as you can see, you don't necessarily have to be near, or judges or advisors aren't necessarily near where schools are. It's great if they are, but with things like Zoom, it's not necessary. Just for fun, I put these three maps there showing locations on the moon where students have examined over the almost past decade. Pretty good spread. So I need advisors for the next year's program. We're gonna start about September. Of course, we'll have to see how school openings shake out given COVID, but we're hoping that's the goal. We'll get started up again in September of this year. If you'd be interested, thank you. If you'd be interested in learning more, you please email me. You can contact me. We can chat about it, or I can send you some information and give you more. And again, it's okay if you don't live near a team. Like I mentioned, we have a pretty vigorous evaluation. We have them take a pre and post moon and asteroid content survey. We don't call it a test because we don't want to freak them out. The attitude towards science survey, this is a survey that we have used. We've taken the data from the past 4 years, actually. And from that data, we have seen statistically significant increases in students' attitudes towards science as a result of participating in this program. We have given them a process of science survey, where they basically just tick off different processes that they've done throughout the program. And then they get a general exit survey to give a chance to tell us what they really thought about it. I mentioned we've done that one study. We published that in Acta Astronautica in 2018. If you're interested in seeing that, I can help you. I can get you that paper. We'll continue to do an analysis of these, the attitudes, looking at this same survey, continue validating the survey and refining it, but also looking to see if we can keep increasing attitudes. And something we want to do now is look at, so we know from the research, as I showed you earlier, that working with scientists will give them positive attitudes and better feelings about science. But what that research did was they put students in a situation where they're working with a scientist, and at the end of that experience, they talk to the students about, Did this impact your feelings? Yes, it did. But what we don't know is what is it about that relationship? What is going on in those communications between a scientist and a student that gets them excited and gets them interested and changes their mind, if it's that drastic. So starting this fall, this is something we want to start looking into using our program. So if you are an advisor for me, I shouldn't say for me, for the students, this next upcoming school year, we'll ask you to be part of that. And I know there's some folks out there listening who have been advisors in the past. I will be contacting you to participate in this study as well. So that hopefully by next summer, next forum, we'll have some early data to talk about in that respect. And why can I not go for? Okay, so I just want to leave you here with a couple of quotes. These are pieces of advice that past advisors have offered to people who might potentially want to advise in the future. Things just to kind of help you know what's expected of you as an advisor. And we can talk more about that too, if you want. What's expected as an advisor versus what's expected as the teacher who is working alongside with the students. So with that, I'll take any questions.
Thanks, Andy. If there are any questions in the chat. If not, I have a question. How are the programs, how are the schools that XMS affects chosen? Or do they have to sign up? Are they selected? Are they public schools? Are they magnet schools? Are there any qualifications that are necessary for this kind of program? What can you tell us about that?
Yeah, so that's a good question. So how it works is teachers are encouraged to apply. They apply, and then we ask them to then think about who are the students they would want to bring on to participate in this. And the number of students that participate varies. They could have a core group of just 3 kids. They could have a classroom of kids or an after-school club of kids doing it. But they always have a very core group, a small core group that kind of is in charge of everything and makes sure everything happens. We've had private schools, public schools. We have even in the past had like an after-school group at the California Academy of Science. They have a program there already, but it's mostly biology related. But for a couple of years, they participated in our program and did lunar stuff and did quite well. So it's all over the place, really. As you saw from the map, it's all over the country for the most part. It's very difficult to choose teams. We'll normally get many more applications than we have advisors, which is my number one thing, by the way. That's the toughest part of our program, is finding advisors, because you're all so busy, and we totally understand that. But that's the tough part. So we take 10 a year, but we get close to 30. It's really hard to down select. And we've tried different ways with the application to try to find things we can pull out to use, but it's difficult. One thing we did start doing this year was, it was voluntary, but a teacher could ask a student to then fill out a short questionnaire we created. So we could use that to see how does a possible student who might participate, how are they responding to some of these questions, and we can maybe use that as a way to differentiate. Paul, how much time? Yeah, that's a good question, Paul. Thanks, Paul. We asked advisors that, and it ranges, to one extreme where teams never contacted their advisor, obviously to their own detriment. Whereas we'll have teams talking to their advisor every day, every other day, a couple times a week, and that's during the program. But even we had one case, and this was fantastic. We had a paper published out of this program about 7 years ago. And while that's not necessary, it's not required, it happened, but it was because the advisor felt so strongly about that project that the advisor worked with that team beyond the school year to get some more data, get the paper a little more polished for publication, and it happened. So that's on the other extreme. I would say 5 to 10 hours a week is kind of what we hear on average.
Okay, so thank you again.